In this video, we will introduce the derivative, which is what we're going to be talking about for the next few months of your math life. So this function, the limit as h approaches 0 of the slope function, plays a central role in calculus. There are two interpretations of this limit. It's the slope of the tangent to the graph y equals f at x. It's also the instantaneous rate of change of y equals f at x with respect to x. This limit is so important that it has its own name. It's called the derivative of f at x with respect to x. And it just means how the function f at x is changing with respect to the variable x. The way of writing this derivative is f prime of x, or we can write it, and we say here, dy by dx. And the first principal definition is that it's the limit as h approaches 0 of f at x plus h minus f at x over h, provided that this limit exists. This is called Newton's quotient, and if you're asked to find the derivative of a function by first principles, also sometimes if you're asked to find the derivative by its definition, this is what we use. So the derivative is so popular that there are many different notations. I think you can also look up stories of feuds between the different people who have been credited with coming up with this mathematical concept. But there are just three of these notations that we're going to use most often, and it depends how the function is presented. So if you're given the function using function notation as f at x, then use this f prime of x notation. If you are given the function as y equals, use the Leibniz notation, which is dy by dx. This will also come in handy because if you want to find the derivative at a certain x value, you just do like f prime at a, like we do with function notation. With dy by dx, we add this bar and the x equals a to show which value we are subbing in. I've included some of the other ones just because you may see them out and about, but we will mainly use the f prime and the dy by dx notation.